So this video is going to explain and prove Theorem 10.3. If two segments from the same exterior point are tangent to a circle, then they are congruent. So in specific, if we have an external point S and a circle with center P, if we have line SR and line ST both being tangent to circle P, then line segment SR equals line segment ST. And we can see that by looking at this diagram here. So again, we have circle with center P. We have an outside point with a label of S. And we have two tangents drawn through S to circle P. One of them is line ST. The other one is line SR. So from this single point external to a circle, we have two tangents, and it turns out the line segment SR is congruent to the line segment ST. So why is this the case, and how can we prove this? What we can do is we can take a look at the diagram here and follow along with the proof. So again, I've drawn a line segment SR tangent to circle P and a line segment ST tangent to circle P, and we need to prove that SR is congruent to ST. Well, the first thing we can do is, from our previous theorem, we know that if we draw a radius from P to R, and if we draw a radius from P to T, we will end up with two right angles, because we know from our previous theorems that a radius is always perpendicular to a tangent if the radius is drawn to the point of tangency. So we can draw in here perpendicular sign to represent the fact that we know that these are both right angles. We can do the same thing down here. So far what we've got is we've got ourselves two right angles, both drawn from the radius and both going to tangent line segments. The next thing we can do is we can draw a line connecting the center of the circle, P, to our external point S. And let's do it as such. Okay. Let's just zoom back in a little bit. Okay, good. Make sure that we're centered right. Let's get right, make sure we're centered correctly here so we can see everything going on. Okay, very good. So what we've got is we've got ourselves the following diagram. Now notice that actually we've created two congruent triangles by drawing line segment PS. We have triangle PRS, which is a right triangle, and we have triangle PTS, which is also a right triangle. Well, how do we know that they're congruent triangles? Well, we know this because we can use hypotenuse leg congruence theorem to prove it. Each of these triangles share the same hypotenuse, which is opposite their right angle, and that is the line segment PS. So we can draw ourselves a little congruent sign that PS is congruent to itself. Notice that in triangle PTS, PS is the hypotenuse, and in triangle PRS, PS is the hypotenuse. So this hypotenuse is congruent to itself. And also notice that all radii are congruent to themselves. So radius RP is congruent to radius PT. So we can draw them both as being congruent as well. Now we have the two triangles congruent according to hypotenuse leg, so that triangle RPS has RP as the radius, whereas triangle PTS has PT as the radius, and that's one of the legs of the respective right triangles, and they both also share the same hypotenuse. So by hypotenuse leg, these two triangles are congruent. But if these two triangles are congruent, then the remaining legs, which would be RS in one of the triangles, and TS in the other triangle would also be congruent as well. So RS is congruent to TS. But RS and TS were the original line segments that were tangent to the circle from a common external point S. And the theorem states that these two line segments are congruent. Because the triangles, the right triangles, are congruent, therefore we do know indeed that RS is congruent to TS, and that proves Theorem 10.3.